So we're going to look at laws of exponents. And we're going to start with the definition of integer exponents. So let's start with our positive exponents. So for example, I had the power of base 3 and exponent 5. And that is going to be equal to 3 times 3 times 3 times 3 times 3. Again, when we talk about powers, this is the base, this is the exponent. And this is called our expanded form of this power. So in general, if I have base a raised to some exponent n, that would be a times, and we would keep on going until we have n factors. So whatever n is, that's how many times we would see the letter a. Next is zero exponents. And for zero exponents, let's say we had 3 to the exponent of 0. That equals 1. And you may already know that any base, let's say a, raised to the exponent of 0 is going to equal 1. And last are negative exponents. So if you were to see negative exponents, for example, 3 to the negative 2. The way we deal with negative exponents is that we flip the base. The base right now is 3 over 1. So if I flip that, this is the same thing as 1 over 3, and then we square it. So we flip the base, which changes it to a positive exponent. And then, of course, this would be equal to 1/3 times 1/3, or 1 squared over 3 squared, which would equal 1 over 9. So in general, let's say we had a to the exponent of negative n. That would be the same thing as 1 over a to the exponent of positive n, which would be the same thing as 1 to the exponent n over a to the exponent n. So again, this is negative exponents, which may be new to you this year. So let's look at some of the laws of exponents. There are 3 that you need to know. The first one is multiplication. So for example, if I had 2 powers, 5 squared times 5 cubed, if I wanted to write this as a single power, since we're multiplying, then that's equivalent to 5 to the exponent of 2 plus 3, which is equal to 5 to the exponent of 5. So when you have powers with the same base and you multiply, you keep the base and you add the exponents. So in general, let's say I had a to the m times a to the n. Since the bases are the same, this would be a to the m plus n. That's our general formula. Next is division. So I have 5 to the exponent 7 over 5 to the exponent of 3. Similar to multiplication, we're going to keep the base, and instead of adding the exponents, we subtract the exponents. So in general, if I have a to the m divided by a to the n, that would be the same base, so we keep the base of a, and m minus n, the numerator's exponent minus the denominator's exponent. And the final one, the power of a power. So I have 5 to the 2, and I raise it to the exponent of 3. So this one, we keep the base when we only have one base, but we multiply the exponents. So we get 5 to the exponent of 2 times 3, which is 5 to the 6. We multiply the exponents and use the base. So therefore our general formula is, if I have a to the m and it is raised to the exponent n, that is a m times n. And that's our general formula. So let's look at a few examples. We're going to simplify before we evaluate each expression. So first one, we have 5 raised to the exponent of 4 times 5 raised to the exponent of negative 2. So this one we're going to use our multiplication rule, which means I'm going to get 5 to the exponent 4 plus negative 2. 4 plus negative 2 is equal to 2, so that's 5 squared. And then we can evaluate and we get 25. So the question says simplify, we stop here. If it says evaluate, you continue on. Next one. Our base is negative 6, and then we have the exponents of 2 and negative 1. And since we are dividing, we are going to use our division rule, or division law. And our division law for exponent says keep the base. So in this case, our base is negative 6, and subtract the exponents. So 2 minus negative 1. Make sure you put brackets around that base. So that's negative 6. And then 2 minus negative 1, that's going to be positive 3. So that is negative 6 times negative 6 times negative 6. And since we have 3 negatives, this is going to be negative 216. If it was squared, it'd be positive, but since it's an odd exponent, we're going to end up with a negative number. All right, next one. We have m raised to the exponent of 5, and then that is raised to the exponent of negative 3. Notice we only see one base, but 2 exponents, so here we're going to use our power of a power rule. And this gives us that we're going to have m raised to the exponent of 5 times negative 3, which is m to the negative 15. So we need to deal with the negative exponent. Remember to make it a positive exponent. Since that's m over 1, this would be 1 over m to the positive 15, which is equal to 1 to the exponent 15 over m to the exponent 15. And if you're okay, you can go right to this step. This is 1 over m to the 15. Because 1 times 1 times 1 times 1, as many times as you want, still equals 1. M times m 15 times is m to the exponent 15. So if you're okay, you can go right from this step to this step. So we have to do some order of operations, and actually we can do 2 things at once. We can start with the numerator, and we can then deal with the denominator at the same time. In the numerator, I'm going to use my multiplication rule. And for the denominator, I'm going to use my power of a power rule. So let's do that. Our multiplication rule says I'm going to add the exponents, so 2 plus negative 5. And my power of a power rule says I'm going to multiply. So this is negative 2 times 3. So let's do that. We get a to the negative 3 over a to the negative 6. Since I'm now dividing powers with the same base, I'm now going to need my division rule. Division rule states that I keep the base and subtract the exponents. If I do that, negative 3 minus negative 6 is the same thing as negative 3 plus 6. I get a cubed, and I'm done. I don't need to flip the base because the exponent is positive. So 3 rules that we needed for this one: multiplication, power of a power, and our division rule. And the last example. So for this last one, notice we have 3 objects inside the bracket raised to a power. The first thing to note is that 2, since it does not have an exponent shown, there was always a 1 there. So 2 to the exponent of 1 is 2. The next thing is, since there's 3 objects, each object needs to use the power of a power rule. So that 3 I'm going to multiply it by the 1, multiply it by the 5, multiply it by the 2. So again, I'm going to use the power of a power rule. And this is going to give me, well, 2, 1 times 3, that's going to give me 3. 5 times 3, that's going to give me 15. And 2 times 3, that's going to give me 6. The last step is, since we have a number with an exponent, we can simplify that further. So 2 to the exponent 3, that's 2 times 2 times 2, which is equal to 8. And then we leave the variables the way they are. And here would be your simplified expression. 8a to the exponent 15, b to the exponent 6. So again, if there's multiple objects within a bracket, as shown here, each exponent attached to each object needs to be multiplied by the exponent on the outside. And again, this must be multiplication within the bracket, not addition. Here are some examples that you can try.